Today we will discuss the graphs of quadratic polynomials. Here the example is taken, that is p of x. P of x is equal to x square minus 10x plus 16. X square minus 10x plus 16. This is the example. And we have to plot the graph of this polynomial. So we have to take different values of y for different values of x. Suppose we take x is equal to 2. If we will take x is equal to 2, we will get y is equal to 0. P of 2 is equal to 2 square minus 10 into 2 is 20 plus 16. So 4 plus 16, 20 minus 20, it will be equal to 0. When x is equal to 2, y is equal to 0. Here the point is this one. Second is, when we take x is equal to 8, we will get p of 8 is equal to 8 square minus 10 into 8 plus 16. So 64 plus 16, this is 64, 8 square plus 16 is 80 minus 80, that is equal to 0. So the point is 8 and 0. 8 and 0 is the point which is on the x-axis, this one. Now if we will take x is equal to 5, then we will get p of 5 is equal to 5 square minus 10 into 5, that is equal to 50 plus 16. 25 plus 16 is 41 minus 50, that is minus 9. The point is this one. This is the point. This is 5 and minus 9. Now these three are important points. First point is x is equal to 2, 0. This is the 0 of the polynomial. 0 of p of x. And x is equal to 8. Here 8 and 0. This is also 0 of the polynomial. Here two zeros are positive zeros. Value of two zeros, alpha and beta, both are positive. And 5 is the, you see this is at 5, x is equal to 5. At x is equal to 5, y is equal to minus 9. This point is called the vertex of the parabola, vertex of the graph. Well, this shape, if you take all the points related to x, then we will get corresponding values of y. And the shape thus formed after connecting all the points is looking like a U structure, which is called a parabola. The structure of the graph of the polynomial is a parabola. And here we define the vertex. Vertex is either the maximum point or the minimum point of the parabola. Vertex of the parabola, vertex is the minimum or maximum value of the px. So here the graph is opening up. That opening up means it is in this way. That means it has a minimum value. When the graph opens up, it has a minimum value. And if you observe here the coefficients of p of x Suppose we are taking p of x as ax square plus bx plus c, which is a standard polynomial, and here we compare this with the given example minus 10x plus 16. Here the coefficient of x square is 1, that means a is equal to 1, so a is greater than 0. If a is greater than 0, the graph is opening up. You have to remember this one. If a is greater than 0, the graph opens up and we will have the minimum value of the parabola, minimum value of the px. And here if you will see this line, that is here if you take any point x is equal to 5, hence this line is described as x is equal to 5, which is the axis of the parabola, axis of parabola, and passes through vertex. Now consider the second case. P of x is equal to minus x square plus 4x plus 5. If we will take p of minus 1, we will get minus of minus 1 square plus 4 into minus 1 plus 5. So this will be equal to 1 minus 1 minus 4 plus 5. This is equal to 0. So we will have this point minus 1 and 0. So minus 1 and 0 is the 0 of this polynomial. Similarly, if we will take p of 5, we will get minus 5 square plus 4 into 5 plus 5, that is equal to minus 25 plus 20 plus 5, this is equal to 0. So the point 5 and 0, this is also 0 of p of x, where the polynomial px cuts the x-axis. So this point is 5 and 0, which is the 0 of the polynomial. Similarly, if we will take p of 2 here, now p of 2 will be equal to minus 4 plus 8 plus 5, that is equal to plus 9. Minus 4 plus 13, that is plus 9. The point is this one. This is 2 and 9. This is the vertex of the parabola. The maximum point, we will define the formula actually. First you just see the graph. 2, 9 is called the vertex of the parabola. So point 2 and 9 is the vertex of the parabola, vertex of p of x. And here if you will compare this polynomial with the standard equation, we will find a is equal to minus 1. This is ax square plus bx plus c. This implies here a is equal to minus 1, which is less than 0. If a is less than 0, graph of the parabola opens downwards, and here we will have maximum value of px, maximum value of px, and there will be no minimum values, because minimum values may be minus infinity. Similarly, in the first case, when a is greater than 0, we get minimum value, but there will be no maximum value, but actually it will tend to infinity. We will not get any maximum value in case of a is greater than 0. For a is less than 0, we will have maximum value and there will be no minimum value. Maximum, no minimum. Here x is equal to 2. If you will see, this is the axis of the parabola. If you will take x is equal to 2, this is axis of the parabola. X is equal to 2 is the axis of parabola as it passes through the vertex, and about this axis of the parabola, that is p of x, and it passes through the vertex. Now take the example here. If the given figure shows the graph of the polynomial y is equal to x square plus bx plus c, which condition will satisfy? You see here, there are two zeros. This is the graph. There are two zeros. One zero is here and another zero is here, and two zeros are positive. Two zeros are greater than 0 because this value is positive as it lies on the positive x-axis. This value also greater than 0. Next is graph is opening down. Graph opens down. What we will conclude here? A is less than 0. A is less than 0 means A cannot be greater than 0. Now second thing is A and B are of same sign. You see, alpha plus beta, alpha is 1 0 and beta is the other 0. We take this as alpha and beta. This is alpha and this is beta, suppose. Both are greater than 0. So alpha plus beta is greater than 0. We know that alpha plus beta is minus b by a. So minus b by a should be greater than 0. But a is less than 0. So what will conclude? If a is, this implies if a is less than 0, b will be greater than 0. If a is less than 0, b should be greater than 0, so that b by a should be greater than 0. B should be greater than 0, so that this will have positive value, because this should be greater than 0. So B is greater than 0, that means A and B both are opposite sign, not same sign, both are opposite sign. A and B are of opposite sign. Next is B square is less than 4AC. If B square minus 4AC is less than 0, then there will be no real zeros. There will be no real zeros. No real zeros. Because we know that alpha or beta, alpha suppose we are taking, there is minus b, or alpha or beta minus b plus minus square root of b square minus 4ac by 2a. If b square minus 4ac is less than 0, then it will not be having real values. So option A is correct.